In this video, I'm going to briefly share with you about how to identify the three basic components of a signal. Yeah, so all signals have three components. The amplitude, the frequency, the phase, okay, and then amplitude is the height of the wave above or below a given reference point, and amplitude is usually measured in volts. Figure 2.6 shows a signal with two different amplitudes. So you can see that if we use this horizontal line as a reference point, and then you can see that in this section, the signals has a low amplitude, but then for this waveform here, okay, yeah, then within this interval, then you can see that it has high amplitude. Okay, so and then you go back to the low amplitude according to this signed form. Okay, all right. Okay, and then frequency. Okay, so frequency is the number of times a signal makes a complete circle within a given time frame. And then frequency is measured in hertz, short for Hz, or cycles per second. Let's take a look of the figure here. So figure 2-7 shows three signals of A. This one will be the A, 1 hertz, and then B 2 hertz, and then C, figure C, 3 hertz. So again, the frequency represent the number of cycles completed within a given time interval. So assume that we want to use 1 second as the time unit. Then in the figure A over here, then you can see that based on the sine wave, then it complete 1 cycle here. So we call this one has 1 hertz. And then for the figure B, you can see that the sine wave complete 2 cycles. From here go up to here, and then go one more time. So this one will be 2 hertz. And then how about figure C? Figure C has 3 hertz. So again, 1 cycle, 2 cycles, 3 cycles. So we say that this one has the frequency is 3 hertz. Yeah. But at the same time, you might also heard about the term period. Period is the length or time interval of 1 cycle. It's called a period. And then how do you find it out? The value, you just take 1 divided by the frequency. So if again we use this one as an example, then you can see figure A, the period of figure A will be 1 divided by 1 will be 1, 1 second. And then the period of figure B will be 1 divided by 2. Then it will be 1 cycle. Takes 0.5 seconds. And then figure C will be 1 over 3. Or you can think of as 0.3333 seconds. Okay. Yeah. All right. And then you might also heard about the term spectrum. Spectrum is the range of frequencies the signal spans from minimum to maximum. You might also heard about the term bandwidth is the absolute value of the difference between the lowest and the highest frequency of a signal. Okay. Yeah. So let me yeah. So over here it use the average an average voice, and then the example. So the average voice has a frequency range from roughly 300 cycles per second to 3100 cycles per second, or if you want to call it hertz, is fine. Then in that case, the spectrum will be between 300 to 3100 hertz. And the bandwidth will be the difference between the lowest value and the highest value, right? So in that case, it will be 3100 subtracted by 300, then it will be 2800 hertz. So that will be the bandwidth. Yeah. Okay, and then how about the third component? The phase. Phase is the position of the waveform related to a given moment of time, or related to time zero. A change in the phase can be any number of angles between 0 and 360 degrees. And the phase changes often occur on common angles such as 45 degrees, 90 degrees, 135, etc. Okay. And then figure 2-A shows a sine wave showing A, no phase change. So this one is A. B, 180 degree phase change, and the C, a 90 degree phase change. So again, let's take a look of the figure A over here. So again, the sine wave, assume that we call this one is one time interval, or one time unit. Then you can see that the next one it did not change. The next one it did not change. So during those time intervals, you can see that no phase change at all. Again, this time unit. Okay. But then how about figure B? Figure B, you can see that it has a 180 degree phase change. I use this picture here to shows the number of degrees. So I kind of divide this sine wave into 4 sections. Okay, 1, 2, 3, and 4. Okay, and then here will be 90 degree, 180, and then 270, and then 360 here. Okay, so you can see that during this point of time, the sine wave completed, and then you will go up to 90 degree theoretically, and then it should go down, right? But then during this point of time, actually it directly drop, or connect to this waveform over here, and then again we just count this one as 90 degrees, this one another 90 degrees, then it shows that there is a phase change of 180 degree phase change. Okay, so this is how you can see it. Okay, and how about figure C? So again, this one go up to 90. The next one it should go down here, right? But then this part is missing. So which means that instead of going down here, then this phase directly shift to the left. So we call this one has a 90 degree phase change. Okay. Next slide, I kind of look into the information from the this section related to phase. But then I couldn't locate the information over here. But then feel free to skip it if you want to. But then they also put the slides here, so I will just read it to you. But then I'm not going to give you the detailed information. Okay. So phase, if a signal can experience 2 different phase angles, then 1 bit can be transmitted with each signal change. During each BOAD, again later we'll learn about the term here. Okay, if a signal can experience 4 different phase angles, then 2 bits can be transmitted with each signal change. And then note the number of bits get transmitted with each signal get changed is equal to log base of 2 on the value of the number of different phase angles. Okay, yeah. And then we also put a note here. You can replace phase angles with amplitude labels, or frequency labels as well. All right, so I think that I will just stop the video here. Okay, yeah.